So we've reached the part tonight where we get to take a question from our foundation, our inquiries from the foundation section. Every month, our foundation solicits its members for a question to ask us here at Griffith Observatory. And tonight, we're happy to have a question from Byron Hayes. And he wanted to know, what are the observations closest to the Big Bang that have been made? Great question. So the Big Bang, of course, is the beginning of the universe. We think about 13.8 billion years ago, filled with energy. Some of that energy gets turned into particles back and forth. Eventually, the particles separate from that energy. However, what can we actually see? What can we look back on? Well, the furthest galaxy light, so sort of starlight that we've seen, is from a source called GNZ11. And indeed, it has a redshift, or Z, of 11.09, which is ridiculously big. The light traveled 13.4 billion years to get to us. So when the light left us, the universe was only about 400 million years old, if these numbers are correct for this galaxy. The proper distance, meaning how far is it right now, it's 32 billion light years away, because the universe has expanded in that time it took the light to get to us. So the thing is a lot further away now than it was when it left. And the constellation it's in is in Ursa Major. Now you can see the data that were responsible for this. Now, a little bit confusing, but hang with me. I'm not going to spend too long on it. But you can see here the data is the red. It has a sharp incline and then sort of smooth with little dips in it. Well, this over here is the bluest light that is going to get created. It's sort of a drop off there in the starlight. So we can look for that in models. So they go in and fit this, and that's how they get the redshift. Could it be wrong? Sure, it could be wrong. This is the best guess they have to find it. It's very difficult to do these sorts of observations. And this is the reason we're excited to get things like the Europeans' extremely large telescope, TMT, wherever it eventually does get built, whether it's on Mauna Kea or moved off to another site. That's a discussion for another time, folks. And also, of course, the James Webb Space Telescope will give us observations from space that'll be able to see a lot of these objects. Now, this isn't the furthest thing we've seen or the thing that is closest. Really, the thing that is closest to the Big Bang we've seen is really the cosmic microwave background radiation. That is a real surface. That's when the universe was opaque. It's sort of in every direction. It was glowing nearly as brightly as the sun, and it was opaque like the sun. So if you want to see that surface, that's what you can look back to and actually hit it. It's only about 379,000 years after the Big Bang. So it's a little bit further back. It's a little bit closer. So that's our main questions from the foundation. We had another great question from Brian Ferguson, who wanted to know, we can approach the speed of light, but Einstein's equations and our measurements and every bit of physics we've ever done says you can't go faster than it. That things happen, special relativity, general relativity kicks in. You can't get past it. It's a physical limitation. He wants to know, or what concepts to get past it. What can we do about that? Well, you can't go faster than the speed of light. That's just impossible. But what you can do, you can mess around with a distance. You can do things like fold space. You can tunnel through space. You can warp it and make the distance shorter or find a way around. So we cannot travel through our own space faster than light, but maybe you could go outside of it. So great question, but you weren't the main question this time. If you have other questions, or Brian, if you have a different question, you want it to be the main one, submit them for next month. The foundation also has a very special opportunity. We're really exciting. They have a special announcement coming from them. Plans to reopen the observatory are in progress right now. So that's brand new news. I don't think anybody's told anyone this yet. We don't have a date to announce, but it's going to be coming soon. And the foundation is going to host a special night just for members. So this is your chance to join the foundation and go see Griffith Observatory before we reopen to the public. And this is going to happen on, this is our first on-site event since February 2020. And we're excited to have members come back, take a look at some of the changes, take a look at the, all the exhibits. It's going to be a lot of fun. The Samuel Ocean Planetarium will be open. The Leonard Nimoy Event Horizon Theater will be open. Opportunities to look through telescopes. So, it's time to join or renew your membership, and then you can come visit the observatory on June 18th. It's super, super exciting. And, we haven't been closed for 15 months like this in a long time. It was unexpected, unprecedented. So with contributions from the foundation, we were able to create an online presence. We were able to do some new things. So thank you to the foundation. This is an opportunity to thank them. And soon enough, the rest of you will be able to come join us too.